Hello everyone and welcome back to the tutorial series. In this part of the tutorial, we will go over GameLift's auto scaling features, which you can use to minimize hosting resources and costs while hosting game servers on Amazon GameLift. As the number of active players in your game increases, GameLift can start up new EC2 instances in your fleet in order to accommodate for the increase in player demand. As the number of active players in your game decreases, GameLift can shut down unneeded EC2 instances in your fleet in order to save money while still making sure that there's enough capacity to handle the current player load. Throughout the existence of your game, the number of people playing your game will constantly change. As a result, the least amount of hosting resources you need to ensure that each player is able to connect to a running instance of your Unreal Engine server in a timely fashion will also constantly change. By experimenting with different auto-scaling policies, you can get very close to optimizing your EC2 instance usage and costs to the least amount it can be. Special thanks to our patrons on Patreon as well as anyone who has donated to us. We really appreciate the support. With all that said, let's get started. Now before we get started, I just want to point out that unlike the past parts of the tutorial, it may be easier to just watch and see what's going on rather than strictly follow exactly what I am doing in this video. However, whether you just watch and listen or follow along with what I am doing in real time, just note that keeping up with me while watching the video may be difficult and that trying to replicate the steps taken in this video after watching the entire video may be a better alternative approach. So first, I want to take a step back and explain scaling in general in terms of GameLift fleet capacity. So like we mentioned in past parts of the tutorial, a fleet is a collection of EC2 instances, which are virtual computers, each used to host 1 to 50 instances of your Unreal Engine game server concurrently. The term scaling in this sense means changing the number of active EC2 instances in a fleet, whether it's increasing or decreasing the number of instances. We've actually already had experience throughout this tutorial with scaling, however it was not auto-scaling since we never created an auto-scaling policy. Nevertheless, I always try to recommend to you guys to set the number of instances in your fleet to 0 so that you don't get charged when no one is playing your game. And this is technically manual scaling. Just to refresh your guys' memory, let's open up the GameLift dashboard in the web browser of your choice and select the Linux fleet that we made from the last part of the tutorial. And if we go to the scaling tab and then scroll down to where it says auto scaling policies, specifically where it says manually adjust the desired instance count to, and now this number at the end here should say 0 if you are not currently testing your game. Now, when this number gets changed and the change is saved, a scaling event occurs. If the number was changed to a larger number, then GameLift starts spinning up new instances, hence new game server processes, until the number of active instances equals the desired instance count that was manually set here. If the number was changed to a smaller number, then GameLift will find either instances that aren't hosting active game sessions or unprotected instances that are hosting active game sessions and terminate them until the number of active instances equals the desired instance count that was manually set here. Now, throughout the tutorial series, we always work with either 1 or 0 instances because we were just testing, and that is the default minimum and maximum instance count set in the instance limits. So if you tried manually scaling your desired count to a number greater than the maximum or less than the minimum, you will find out that you are not allowed to. So just for testing, you don't have to do this, but I'm going to try to make this number a number greater than the maximum instance count. And you're going to find that when I click the check mark to save and apply my changes, you'll see this exclamation point pop up here, and if you hover over it, you'll get an error. So let me click the X button to disregard my changes, but keep in mind that any number within the instance limits range up here, inclusive on both ends, is an acceptable value for this manually adjusted desired instance count to field. Note that you can also change the limits up here as well, but we will talk about that later in this part of the tutorial. So that leads us to why we need auto scaling, because like the name implies, auto scaling consists of one or more policies that can trigger scaling events automatically when certain GameLift metrics are reached. When a game is no longer in the development or testing phases and is in the production or release phases with large and different amounts of players playing the game every day, you may need more than one instance. You may need 2 instances, maybe even 5, 20, or more. And although you can always increase your instance limits and then manually adjust the desired instance count yourself, this is highly inefficient and not scalable. That is why auto-scaling becomes very useful, because the desired instance count gets set for you by GameLift, and the scaling event gets triggered the exact same way it does for manual scaling. The difference is that manual scaling requires you physically to change a number, while auto-scaling requires you to create a policy. But after that, the number of active instances changes automatically depending on your policy. Now, what is an auto-scaling policy? GameLift provides us with 2 types of policies that you can automatically scale your fleet capacity with. The first type, which we will be primarily going over in this video, is target tracking, which is based on a single fleet metric, game session availability percentage. Basically, when you create a target-based policy, all you have to do is set one number, also known as the buffer, which is the percentage of game session availability that you want to maintain in your fleet. And all that is the number of server processes running on all the active instances altogether in your fleet currently that are not hosting a game session, divided by the number of server processes running on all the active instances altogether in your fleet currently, times 100. Once the current available game session percentage falls below the buffer for a certain amount of time, GameLift will calculate the number of new EC2 instances needed to bump the current game session availability percentage above the buffer. Then the desired instance count is increased by the number of new EC2 instances that need to be started up. And when the current available game session percentage is above the buffer for a certain amount of time, GameLift will periodically check if any EC2 instances can be terminated while still maintaining the game session availability percentage above the buffer. If so, then the desired instance count will be decreased by the number of instances GameLift calculated to shut down. The second type of auto-scaling policy, which we will not be implementing in this video, but I still wanted to briefly mention, includes rule-based policies, which can only be made through the AWS CLI in the command prompt or terminal, not through the dashboard, but they give you more granular control on how your fleet capacity scales in response to more fleet metrics in addition to game session availability percentage. For example, number of activating game sessions, number of active game sessions, number of available game sessions, number of active instances, number of current player sessions, number of idle instances, and more. Also, you can specify what has to happen to that metric for a scaling event to occur. This includes the comparison operator, so whether a metric becomes less than, greater than, or equal to some value, the threshold value, which is that value we just mentioned, and the evaluation period, which is how long the metric is within the threshold value depending on the comparison operator. Lastly, you can even specify how you want the fleet capacity to change exactly, whether it's removing or adding instances by an exact number, by a percentage, or just setting the number of instances to a fixed number. So as you can see, rule-based policies are much more powerful and specific than target-based policies. However, GameLift recommends target tracking policies because they are much easier to make and get started with for beginners, but a combination of both target tracking and rule-based scaling policies used together can help optimize your game's hosting resources and costs for specific edge case scenarios. For most scenarios, however, a simple target tracking policy is very effective and should be enough. By the way, links to the 2 articles of documentation that were just shown, as well as other very useful pages from the GameLift developer guide with regards to auto-scaling and scaling in general, will be in the description below. Moving on, let's go back to the GameLift dashboard, specifically this fleet details page. So just a reminder, if this desired instance count number down here is not 0, then please set it to 0. Click the checkmark button to save your changes, because I want to make some minor changes to this fleet first before running active instances within this fleet. So make sure it is 0 and keep refreshing the page until the number up here by where it says active instances and active servers are both 0. And once that is confirmed, let's edit our fleet really quickly by clicking where it says actions and selecting edit fleet. On this page, I just want to make a couple of changes. So first, if we scroll down to the process management section underneath where it says server process allocation, just to better explain and show auto scaling in real time, I'm going to delete all but one of these server processes, because since target tracking relies on game session availability, the less available game sessions there are, the easier it will be for me to trigger scaling events. Again, this is just for testing purposes. For a real-life production game, you should definitely try to run as many server processes as you can while not hindering performance. Otherwise, you are paying money for hosting resources that you are not fully leveraging. By the way, the number of available game sessions is just the number of server processes that are not currently hosting a game session. One server process can host at most at a time one game session. And since we did remove a number of server processes, let's modify the port settings. So down here under where it says EC2 port settings, to only have the one port open that our only configured server process is running on, since we're no longer using the other ports in that range in the second entry in this table. In my case, let's click on the pencil icon and let's remove this range and just replace it with the port of now our only configured server process, which in my case is 7777. Once you have made your changes, go ahead and click the green check mark button to save your changes. Lastly, I want to change the protection policy from no protection to full protection. And I should have done this earlier in the tutorial series, right after we modified the game server to properly terminate game sessions and recycle server processes for hosting new game sessions. The reason I left it on no protection is that if you didn't have the server logic and you wanted to terminate instances in your fleet, but you had active game sessions in those instances in your fleet, then those specific instances could not be terminated if the protection policy is on full protection, unless you terminated the entire fleet. Because full protection is specifically meant for protecting instances that are currently hosting active game sessions from scale down events. Keep in mind that a full protection policy won't protect those instances from terminating due to poor health or spawn interruptions. They will only prevent instances that are currently hosting active game sessions from terminating due to scale down events. But going back to why I didn't change the protection policy's default value until now is that before, at least in the tutorial, we only tested with at most one instance in a fleet at a given moment in time, and we didn't implement any auto scaling policies, so the protection policy didn't make a difference. But for a production game and release, I would recommend using full protection, because you don't want GameLift to shut down instances that are hosting active game sessions on server processes with players in them during a scale down event. With all that said, let's go ahead and submit our changes. Now that we have made our fleet configuration changes, let's manually scale the fleet so that there is one active instance with one active server process. So scroll down to where it says auto scaling policies and manually adjust the desired instance count to change the number from 0 to 1, and click the check mark button to save your changes. And then just here and there, just periodically refresh the page until where it says active instances and active servers, it says 1. Once there is one active instance and one active server, let's scroll down and modify the maximum and minimum instance count. First, let's make the maximum instance count 6, because we will be testing with a lot of clients in this video. And like I mentioned earlier, we need to increase this upper bound because the desired instance count cannot be set, whether it's by manual or auto scaling, to be above this maximum instance count. Therefore, the number of instances will never be scaled above this number, which in this case is 6. So let's click that check mark button to save our changes. Now, if you have trouble doing this, then that means your AWS account is most likely too new and that you need to contact AWS. We will have information about that in the description below. And moving on to the minimum instance count, let's set this number to 1. And this number has to be at least 1 when you are implementing auto scaling policies within your fleet, because what will happen is that if you keep this minimum instance limit as 0 while enabling auto scaling, then what will happen is that when there are no active game sessions going on, the fleet will scale down to 0 instances, and in that case there are no metrics being emitted, so the fleet can never scale back up from 0 instances. So it will be stuck at 0 instances instances until you manually scale the fleet up again, which will require you to disable all of your auto scaling policies first before you can manually scale the fleet up again. So to prevent this issue from happening, set the minimum instance count to a number greater than or equal to 1 in order to prevent an auto scaling policy from scaling the fleet down to 0 instances, because like the maximum instance count, the desired instance count will never be set to a number below the minimum instance count. So the number of instances will never be scaled down to a number lower than the minimum instance limit, which in this case is now 1. So click the checkmark button to save your changes. Now let's implement a target tracking auto scaling policy. So click the box by where it says maintain a buffer of 15% game session availability. And then in this box here where it says 15, let's replace that with 40. Again, the numbers are arbitrary. They can be anything. I just chose that number for testing purposes. And then go ahead and click the checkmark button to save and apply your scaling policy. And then if you scroll down the UI here, you should actually see your new target-based policy enabled. Now, before we spin up a bunch of clients, I want to open this page up again in a separate tab because I want to show 2 graphs. So make sure you're either in the metrics or scaling tab. It doesn't really matter. Since by default I'm in the scaling tab, I'll stay here. The metrics tab is basically the same thing in terms of this chart or this graph here. It's just that the metrics tab has more metrics, but for our purposes, either tab will work. So in this graph, what I want to show is first, I want to disable the default metric. So by default, it shows idle instances and active instances. So I'm going to click on those 2 points to disable those metrics in this graph. And I want to enable % available game sessions. And I also want to enable available game sessions. And then for the time period, let's change this from 8 hours ago to 0 hour ago. For the preset, let's change it from last 8 hours to last hour, and then click apply, and then keep the granularity at its default rate of 1 minute. And then for the refresh rate, let's change it from never to 1 minute. This graph will be useful for looking at what happens as scaling events occur, what trigger them to occur, and how the game session availability changes in response to not only scaling events, but also as clients join games. Now let's go back to the other fleet page we had here in another tab. Let's scroll back up. We're also in the scaling tab here. So as I said earlier, by default, the metrics that are enabled in this graph are the active and idle instance counts. So I'm actually going to turn off the idle instance count. So I'm going to click on that metric to disable that. And then for the period, I'm going to make it the same as the other graph. So for the preset, let's do last hour, click apply. Keep the granularity at its default of 1 minute, and for the refresh rate, let's change it from never to 1 minute. And if I didn't explain it before, the point of the refresh rate is so that the graph refreshes on its own in this UI without refreshing the web browser. And this graph will be useful for seeing how the number of instances increase and decrease as scale up and scale down events occur. With all of that said, let's start up a bunch of clients now. So for this video, I'm going to start up 10 clients at once because that is the minimum needed to start 3 game sessions, which are each hosted on 1 server process. And since there is now only 1 server process running on each instance in this fleet, 3 matches will require 3 instances in this case. Alright, once you have 10 clients open up, make sure you have at least 10 user accounts made. I just did that off screen. I also had to resize each of the clients so that all 10 would fit on the screen. And don't forget to log into a unique and different account in each one of these game clients. I do want to quickly clarify that you don't necessarily need a minimum of 10 clients to get into 3 matches, hence 3 game session. It's really worst case you need 10 clients at the first 2 matches and the backfilling and contain 4 players each. The minimum needed is actually 6 clients, but I want to be safe and open up 10 just in case, so go ahead and click join game for 2 of these clients only, since that's all we need to start 1 game session. So once 2 players are in a game, go back to the dashboard And you will notice that we only have one active instance currently. That is because nothing changed yet on this end. We set the minimum instance count to 1, and then we created a match with 2 clients, hence an active game session. Now, if we go back to the other graph, the number of available game sessions and game session availability percentage haven't been updated yet, but they will when the graph refreshes. So right now, it's still as if the newest game session hasn't been made yet. So we have one available game session out of one possible game session total. Since we only have one instance running currently, and each instance in our fleet runs one server process concurrently. So 1 divided by 1 is 100%. That's why the orange line lines up with the figures on the right side, and the blue line lines up with the numbers on the left side. So what's going to happen is very shortly, these two lines will go down to 0 because now there are 0 available game sessions out of one total game session, which denotes a 0% game session availability rate. And because that number is lower than our specified buffer of 40%, a scale-up event will be triggered, so the number of instances will increase. Now the question becomes, what will it increase to? So hypothetically, taking the current figures, if you added one more instance right now running one server process, hence adding one available game session, you will have one available game session out of 2 total game sessions, assuming the other is still active. That gives you a game session availability percentage of 50%, which is greater than the buffer. So wait about 3 to 5 minutes while monitoring this graph, because it does take time for new instances to start up, and what you will see is the number of available game sessions shoot up to 2. Alright, and after waiting, in my case 5 minutes, you can tell because the granularity of this graph is set to 1 minute, so the distance between each dot on the graph is 1 minute. There are 2 available game sessions, hence 100% game session availability, since the last match we started ended by now. And if we go to the other graph, you will now see that there are 2 active instances, which makes sense in our current fleet configuration. So let's take advantage, since there are currently 2 active instances, so we could potentially start 2 concurrent matches. Let's go back to our clients and click the join game button on 2 clients at a time, because once again, we want to minimize the amount of clients used to get into 2 matches. We don't want a worst case scenario where we use too many clients and a group of clients get placed into a match, but there isn't an available server process to host a game session for that match, which results in a very long wait time because our queue timeout is pretty long, 10 minutes, which is greater than the amount of time it takes to start up a new instance. So if the players are patient enough, they will eventually connect to a server process, but I want to keep this video as clean as I can and assume best case scenarios in which wait times are somewhat optimized. So let's go back to the graph in the GameLift dashboard, and the number of instances won't change right away. In fact, what we just did with the clients proves that there are indeed 2 active instances because we were able to get into 2 separate matches, hence 2 separate server processes. Now if we go back to the game session graph, you will see as the graph refreshes, the number of available game sessions as well as the game session availability percentage will go down to 0, because currently out of the 2 game sessions, both of them are currently active, leaving 0 available game sessions, and 0 divided by 2 is 0. 0% once again is below the buffer, so a scale-up event will be triggered. The question becomes, how many new instances will start up? So the same logic as before applies here. Take the current information and add 1 new instance. That's 1 more available game session, so the percentage of available game sessions becomes 1 divided by 3 total, since the other 2 are currently active, which equates to 33.33%, which is still below the buffer. So let's add another instance hypothetically. Now we have 2 available game sessions out of 4 total, which equates to a percentage of 50, which is above the buffer of 40. So in about 3 to 5 minutes, we should see 4 available game sessions and 4 active instances. So wait that time and come back after. So as you can see, the number of available game sessions went down to 0 after the graph refreshed, and after waiting a little bit, we now have 4 available game sessions with availability game session percentage of 100%, since the 2 matches we created ended before the 2 new instances finished spinning up. And if we go back to the other graph, we should see 4 active instances in this fleet, which does indeed correspond with 4 total game sessions in this fleet at a 100% availability rate. So let's go back to the client, since we can now host up to 4 available game sessions, but I want to keep scaling up slowly to better show you guys exactly what's going on. So once again, click the join game button on 2 clients at a time, but this time to minimize the amount of clients we need for 3 matches. And once you connect enough clients to activate 3 game sessions on 3 server processes, 1 session per process. I got lucky here because my second match didn't backfill, so that's why I only used 8 clients. Again, worst case minimum, when the first 2 matches backfill to contain 4 players total each, you will have to use all 10 clients for 3 game sessions. But back to the GameLift dashboard, specifically the game session graph, you will see the number of available game sessions go down from 4 to 1. Right now it's at 2, but after the graph refreshes, it will go down to 1. So with that said, the percent of game sessions that are available right now is 1 divided by 4 because 3 of them are currently active. So that is 25%, which is under the buffer of 40%, so this will trigger a scale-up event. And the question once again becomes, how many new instances will spin up? So hypothetically, if we took the current data, added one more instance, that's now 5 active instances and 5 total game sessions, with 2 of them being available. 2 divided by 5 is 40%, which is exactly the buffer amount, so one more instance will be added since that is not enough. I believe GameLift will try to achieve a game session availability percentage above the buffer. So with 2 new instances, the total number of game sessions would be 6, with 3 being available, which is an availability rate of 50%, which is above the buffer. So let's wait 3 to 5 minutes once again, and when we come back, we should see 6 active instances and 6 available game sessions, as all the matches should end before these new instances start up, which is an availability rate of 100%. So after waiting, we now have 6 game sessions with an availability rate of 100% as we predicted. And just to confirm with the instance graph, we also have 6 active instances. And that's all the testing we're going to do with regards to scaling up. We could theoretically spin up more clients to get into 4, 5, or even 6 concurrent game sessions, but there's not much of a point because our maximum instance count is 6. So no matter how much the player activity increases, no matter how much the available game session percentage goes down, the number of instances at this point will never scale above 6, which is the limit that we have just reached. The same argument, like I just mentioned earlier in this video, applies to the minimum instance count as well. The number of instances in a fleet under no circumstances will ever scale down below the minimum instance count. So now to transition to scaling down, I want to show you guys how to automatically scale, or how automatic scale down events work. Scaling down the number of instances and actually shutting down existing instances takes a lot longer than scaling up the number of instances and starting new instances. We saw that starting new instances generally took about 5 minutes. For terminating instances, it will generally take about 10 to 15 minutes. Now, I want to gradually scale down the number of instances, just like how we gradually scaled up the number of instances. But now we are going in the opposite direction. So let's go back to the clients and click on the Join Game button on 2 clients at a time until 2 separate matches are made. Once that's done, let's go back to the GameLift dashboard, and as the graph refreshes, the number of available game sessions will go down from 6 to 4 since we just activated 2 game sessions. So the percentage of game sessions that are available now is 4 divided by 6, which is about 66 2/3%, which is much higher than the buffer, so a scale-up event definitely won't occur. But the question now becomes, can instances be shut down while preserving game session availability percentage above the buffer? So let's try doing that with the data now. If you take away one instance, you are left with 5 total game sessions, 3 of them being available. That gives you an availability rate of 60%. Which is still higher than the buffer. So let's try taking away another instance. That leaves us with 4 total game sessions, 2 of them being available. That gives you an availability rate of 50%, which is still higher than the buffer. So let's try taking away another instance. That leaves us with 3 total game sessions, 1 of them being available. That gives you an availability rate of 33 1/3%, which is below the buffer, so GameLift will only scale down the number of instances to 4, since 3 would give an availability rate lower than the buffer. And 4 instances makes sense because we just scaled up from 4 instances to 6 instances, and to trigger the scale-up event to 4 instances, we ran 2 matches concurrently. So it makes sense that running 2 matches concurrently can also trigger a scale-down event back down to 4 instances. And like I just said, give this some time, again 10 to 15 minutes, because scaling down takes a lot longer. So when we come back, there should be 4 available game sessions running on 4 active instances, which is an availability rate of 100%. And like we just talked about, the number of active instances did scale down from 6 to 4, and if we go back to the game session graph, the number of available game sessions went from 6 to 4 as well, which entails a game session availability percentage of 100%. Now, as you can see in the graph, the number of available game sessions did go back up to 6 before scaling down to 4 again. That is because it takes a while for the fleet capacity to scale down. In my case, it took about 12 to 13 minutes, so let's go back to the clients and continue to gradually scale down the fleet. So let's join a game with 2 clients only to activate 1 game session on 1 server process on 1 instance. Now let's go back to the graphs in the GameLift dashboard, and after the game session graph refreshes, the number of available game sessions will go down to 3, since we now have 1 active one, which means that the percentage of game sessions that are available is 3 divided by 4, which is 75%. And this is above the buffer, so a scale up event definitely won't be triggered, but a scale down event may be triggered. To determine how many instances, if any, will be terminated, let's take the data right now and hypothetically take away one instance, which leaves us with 2 available game sessions out of 3 total. That is an availability rate of 66 2/3%, which is still higher than the buffer, so let's take away another instance, which leaves us with 1 available game session out of 2 total. That is an availability rate of 50%, which is still higher than the buffer, so let's take away another instance, which would leave us with 0 available game sessions out of 1 total. That is an availability rate of 0%. So GameLift will scale the fleet capacity down to 2 instances. Now, I forgot to mention this before while the fleet capacity was scaling down for the first time, but I just wanted to note again that whenever the fleet capacity scales down and you have full protection enabled, GameLift will not choose an instance hosting active game sessions to terminate. GameLift will only end idle instances in this case, idle as in not hosting active game sessions currently. If full protection is not enabled, then any instance, regardless of whether or not it is hosting game sessions, can be terminated in a scale down event, whether manually or automatically triggered. Also note that it is hard to test this, so I don't have a good way of visualizing this, but keep in mind that this is a recommended practice to enable full protection for games released in a production environment, since it's better from a user experience perspective to not interrupt gameplay by terminating the server that players are currently connected to in the middle of a game. With all that said, let's wait 10 to 15 minutes again, and when we come back we should see the number of available game sessions scale back up to 4 and then back down to 2, while the number of active instances will scale down to 2. So looking at the instance graph, the number of active instances did eventually scale down to 2, but it wasn't as linear as when the number of instances scaled down from 6 to 4. As you can notice on my end, it scaled down to 3 instances first after 7 minutes and then down to 2 instances 9 minutes after that. So although it wasn't straight to 2, it did take roughly the same amount of time in total that it took to scale down from 6 instances to 4. And if we look at the game session graph, the number of available game sessions scaled down to 3 first to account for the instance shutting down, but technically the match was still in progress, so the game session availability did drop down to 2 while there were 3 active instances. Hence, the first time it dropped to 2, the game session availability percentage was at 100%, but once the match ended, the game session availability percentage went back to 100%, and the number of game sessions went back up to 3 until another instance was shut down, making the number of available game sessions 2. So to continue gradually scaling down the number of instances, let's not activate another game session. So we won't be using the clients anymore from this point on in the video, and if we do so for about 15 minutes, the number of instances will scale down to the minimum instance count, which in this case is 1, because with no active game sessions, the game session availability will be 100% no matter how many instances you remove. However, just to mention this again, the weird thing is that if the minimum instance count is 0, although 0 available game sessions divided by 0 total game sessions is not 1 or 100%, GameLift will scale down to 0 instances in this case, which can cause issues in a production environment because GameLift will not auto-scale a fleet's capacity up from 0 instances. I'm not quite sure why that is. I believe it has to do with no metrics being emitted when there's 0 active instances. Nevertheless, that is why you should never set your minimum instance count to 0, because if at any point in your game's existence that there's 0 player activity, hence 0 active game sessions, then that leaves an opportunity for your fleet to scale down to 0 instances and never auto-scale back up. You would have to manually scale it back up in this case. So with that said, let's wait another 10 to 15 minutes, and when we come back, the number of active instances should scale down to 1. Consequentially, the number of active game sessions will also scale down to 1. Alright, so we are finally back at 1 available game session and 1 active instance. So you have just witnessed at every step of the way how a fleet's capacity can automatically scale up from its minimum instance count to its maximum instance count, and automatically scale down from its maximum instance count to its minimum instance count. To better visualize this, let's change the time period from which this graph is currently displaying data for. So let's keep the presets as it is, but change the start time from 1 to 2 so that we can display the data from 2 hours ago up until now. This gives us a better idea of what we just went through, how scaling down takes way longer than scaling up, and that throughout this hour plus time period, the number of active instances in a fleet was controlled by one metric, and one metric only, which was the percentage of available game sessions at specific moments in time. So Now that we are done with testing, let's shut down our instances. So I may have forgotten to mention this earlier, but this manually adjusted desired instance count to gets completely ignored once you have at least one auto scaling policy enabled, whether it's target based or rule based. So to re-enable manual scaling, click the checkbox by where it says disable all scaling policies in this fleet, and then click the checkmark button to save your changes. And you'll notice on the UI under where it says scaling policy that our target based policy is now disabled. And then to shut down the fleet again, let's set the minimum instance count back to 0. Click the checkmark button here. And then for the manually adjusted desired instance count to set that from 1 to 0 and click the checkmark button again to save your changes. And then let's occasionally refresh the page until the number of active instances and number of active servers are both 0. And also you can close out of the other instance of the GameLift dashboard open in another tab. Once your fleet capacity is scaled down, I just want to end the video by talking about some considerations that you should make when implementing auto scaling in your game. So one big question that gets commonly asked is, what should my instance limits be and what should the buffer for my target tracking policy be? So this really depends on your game and how many people play it. So with regards to instance limits, we already mentioned it has to be at least 1 for the minimum instance count. Now, it should be greater than 1 if most of the time your game is so popular that you constantly need more than one instance. For example, let's say you configure 20 server processes to run on each instance in this fleet, and your game averages 30 concurrent active game sessions at any given time in a day. Then you probably should increase your minimum instance count to 2 in that situation. As for your maximum instance count, you should adjust it to accommodate for your expected maximum player traffic. So if you occasionally get a spike of 200 concurrent active game sessions at a given time each day, then you should probably set your max instance count to be at least 10. Now, the thing to keep in mind though, as these numbers get bigger, you may reach your service limits for GameLift. What are service limits, you ask? Well, go to where it says fleet up here, click on it, and select service limits from the bottom of this menu. So this page lists out the service quotas for your AWS account in the specific region you have selected, in my case, North Virginia, for the Amazon GameLift service, specifically the number of each type of instance that can be allocated total in this region. The number of instances allocated to a fleet is the maximum instance limit for that fleet. You don't have to be actively using the instances for them to be considered allocated. For example, for this first instance type C5.large, the free tier eligible instance, I have 9 instances allocated to fleets in this North Virginia region out of 20 instances provided total, leaving 11 left over as unallocated. In my case, since I never got rid of the old fleets from previous parts of the tutorial, despite the fact that they are scaled down to 0 instances, they are technically still allocated an instance each, since the maximum instance count for each one of those 3 fleets was 1. So that's 3 instances right there. And as you just saw with the fleet we tested an auto scaling policy with, the maximum instance count for that fleet was 6. So that's the rest of the allocated instances. If I made a new fleet right now that used C5.large instances and tried setting the maximum instance count to something greater than this unallocated number, which in my case is 11, or if I modify the maximum instance count of an existing C5.large fleet so that the total number of C5.large instances allocated to all the C5.large fleets in this region combined is greater than the service limit, which in my case is 20, I would get an error in both cases, preventing me from doing either action. Note that these numbers on this page may not look exactly the same on your screen as they do for me on my screen. If you want to increase your service limits, you can do so by clicking on this request increase button, and that will take you to the support page where you can create a case for a service limit increase. But we are not going to do that in this tutorial, so let's close out of this page and let's actually go back to the main fleets page because I just want to quickly point out that in each region you can only have up to a maximum of 20 active fleets at a time. So if you are no longer planning on using a fleet, then I would highly suggest terminating that fleet. For instance, let's say I want to delete this fleet called GameLift Tutorial Fleet, since it's the oldest one and I haven't touched it in months. I would click on it, then click on where it says Actions and select the Terminate Fleet option from this menu. And then you're going to be prompted, do you want to actually delete it? Just to confirm, go ahead and press the red delete button. And then your fleet should be terminated very soon. But back to things that you should consider when implementing autoscaling. We just talked about instance limits, and the other question is about the buffer for your target tracking policy. So the best answer I can give with regards to what you should use as a buffer is to just try to experiment with different percentage values and see what works best with your use case. For example, if you want to reduce player wait times, then make the buffer bigger, because as you just saw in this video, new instances do take time to start up, and that was with a plain Unreal Engine map. Imagine loading a bigger level and multiple server processes of that level at once per instance. But if your players don't really care that much about wait time and you would rather save some money, then make the buffer size smaller, because with a larger buffer size you pay for extra hosting resources that may not end up getting used. However, there are also other ways to reduce player wait times besides having a big buffer to ensure that you always have a lot of spare capacity, such as increasing your minimum instance count, running as many server processes concurrently on each instance in a fleet as possible without severely negatively impacting performance, adding more fleet destinations to your queue. Remember, you can add fleets from different regions to a single queue, and using various rule-based autoscaling policies in combination with a target tracking policy. And there are also other ways to save money besides having a small buffer, such as using Linux server builds and spot fleets, as well as implementing various rule-based autoscaling policies in combination with a target tracking policy. Unfortunately, the common theme will always be that you have to decide in the trade-off between player wait time and saving money, because the best way to reduce player wait time is to make sure that you have extra capacity on hand to best deal with increases in player demand based on your game's popularity and usage. And extra capacity costs extra money, which is why to best optimize both wait time and costs, you have to experiment with different things like we just mentioned. Look at the data like we just did in those graphs, but feel free to look at other metrics besides what we looked at in this video. Reflect on that data, try something new, and after trying so many different approaches, compare each approach, figure out what worked and didn't work, and combine the aspects that did work into an optimal approach. And that pretty much concludes part 11. I hope you found the video informative. If you did, then please like, comment, and subscribe. Please consider supporting us on Patreon or donating to us through PayPal. Just want to give a special shout out to our higher tiered patrons, which include Max Norris, Elise, BioBlaze Payne, Corone Tatum, Keith Perry, and Solar Tricks. And of course, thank you to everyone else who has also donated to us throughout the channel's existence. We appreciate any donation, no matter the amount. If you want to talk with us, then consider joining our Discord server, as well as connecting with us on our other social media platforms. Links to everything will be in the description below. And as always, have a nice day.